All right. All right, so I'm going to take a little break from writing notes, and let's go over some of the stuff we learned here I got to write it too, man. All right, but I got to get the right pen out here, don't I? I don't know why laser pointer isn't the default. All right, so I got my laser pointer. All right, what do we have here? So everything we're going to look at is kind of review. I just look at we have a venturi right here. Is this an updraft or downdraft? Updraft. Updraft. Okay, what does fuel metering head mean? What is that about?
That's the top of the discharge nozzle.
What is it representing here?
Oh, it's
the distance between the fuel level and the nozzle.
Distance between the float level and the discharge nozzle. That's the fuel metering head. How far this has to be pulled up. All right, and so what's going to pull it up? The fuel up?
suction.
The pressure differential. Okay, pressure differential between here and here. What if this pressure is equal to this pressure?
No go.
Okay, what if we're running this on the ground, and we'll assume we're running it at wide open throttle, and I decide to put shop air into right here.
Don't do it.
Flatten baffles and bellows.
It's a non-compressible float. So am I going to run rich, lean, or just explode this thing?
Super rich.
Super rich. It's going to blow, because why? Because if I'm putting 110 psi here and I have a small negative over here, I'm at, 10 inches of mercury, which would be a vacuum, I am going to put a lot of fuel because it's a difference of potential between the two. Oh no, difference of potential. What does that sound like? Electricity. And you don't even remember what am I measuring? Voltage. All right, so make sure everybody's still there. All right. Why is this unmetered fuel and this is metered fuel?
Because you have the main metering jet.
It says that main metering jet. Because after the main metering jet, it's been metered. All right, so we got some points there. Everybody should understand this one. It's self-explanatory. Okay, mixture controls. I couldn't even figure out where I got these from, but I don't know what kind of carburetor this represents, but this is the kind of thing that you should start to have the ability to start grasping. Just take a look at something like this and say, okay, what's happening here? And take a few minutes and digest it. This is where I want you to go with your educational level. So we'll take a look at this one because it's 51 and that's 52. So first thing we have, what kind of flow do we have? Downdraft. All right. So we have the fuel discharge nozzle right here. So what does that make this orifice right there?
Main metering jet.
Main metering jet. All right. Okay. So we have a suction line that comes into here. So we can add some suction. And then this, what kind of air is this? Ambient air. And if it was, if somebody colored it in like the Stromberg drawings, what color would that be?
Yellow.
Well, you guys are smart. And this would be
Green.
light blue. All right. Well, maybe green. Maybe I'm colorblind. All right. So they're calling this a mixture control valve. So while this is operating, I'm going to have suction applied right here. And as long as this valve is wide open, this suction line is really small. So it has very little effect on anything. There's more than enough ambient pressure coming through here to satisfy not only putting pressure here, but to allow this to rob a little bit off. So the ambient pressure, if you want to think flow, it's going to come in here and flow around through here and into this float chamber. And because this is a suction, it's going to come this way and go out this way because it's suction. Everybody follow me on that one? Okay. So as I start turning the mixture control valve, is this full rich or lean? It's being leaned out. Look, they're throttling this down. You're stopping some of this ambient air come in. So if I lessen the amount of ambient air coming in, what happens to the air over here? It's robbed away. There's not as much to satisfy both the suction and this right here. In fact, if I keep closing it enough, my suction right here is going to be more than this coming in. So if the suction is greater than this pressure, then what happens? It's going to die. But probably what's going to happen more with this type of system is it's just going to have a lot less pressure up here. If I have less pressure up here, what does that mean is happening here?
Less fuel coming out.
Less fuel, because this and this start to match. And the closer they get to matching, the less fuel I have coming out. Would this system work at idle?
Which system?
Why will it not work at idle?
Because the discharge nozzle, the only one, sits below the throttle valve.
All right. So let's close the throttle valve. So now that's closed. Little bit of air is getting through. So what kind of pressure do I have over here now?
Suction.
Okay, so suction or vacuum. So I got a big vacuum over here. What's the air doing over in this area?
And
In this case, it's ambient. Okay, so if I have ambient pressure here, if this is all ambient pressure, what pressure do I have here?
ambient.
What pressure do I have here? So there's no choice but to have ambient here. So I can do anything I want to this, and what's going to happen? Nothing. It doesn't do anything. Why? Because it's all ambient. Doesn't matter if we're coming off the top, coming off the bottom. Doesn't matter. The best you're going to get, and the only thing you're going to get, is ambient pressure out of this whole thing at idle. So it only works at off idle speeds where you have enough suction coming out of the venturi. All right, let's look at this other one over here. See if we can figure anything out with this. This one says idle cutoff. Is this the same as this?
No.
It is not. It is two different designs. So this one, again, we have a downflow, we have a suction right here, but instead of having ambient come in over here, they brought this in over here. So this chamber right here, when it's open, what do I have going on over there? So at idle, and this is called idle cutoff, so it's designed to work at idle. Right now, I've got all this vacuum, and this vacuum is going to come right up into here. And if this is open at all, vacuum's going to work its way around here. And this is a vacuum, and it equals this over here. So am I going to get any fuel out?
No.
No, what they're not showing, that's a discharge nozzle. But what discharge nozzle is that?
Main.
It's the main. Is it working now anyway?
No.
Nope. So the fuel's coming out down here somewhere. Not the best drawing. I don't really know. Let's think what this is for. So as the throttle opens, what's going to happen to this pressure?
Increase.
It's going to increase. Really, very good. And if I open this up, let me see. Which pressure is
Correct.
is it going to keep working?
Yeah, it'll work because eventually, once you open throttle, you will have ambient in the fuel chamber. But
Okay.
you have
But we got to get ambient. This is a weird drawing. You got to get ambient in here somewhere. I don't know where the heck it's coming from. You can't have suction.
If you open throttle, you get ambient in
Okay,
there. Right?
open the
After
throttle.
the Venturi, then
We get-
only in the Venturi there's a vacuum. So after the Venturi, it's not a vacuum, correct?
So this is not a vacuum anymore once the throttle is open.
So
It's-
that would be the ambient.
But look at this. It's got to always be compared to this, right?
Correct.
So this right here, best case scenario is going to be what PSI?
1 inch below ambient.
Okay, so how many inches?
30.
29.
29. 29. So 1 inch. So 30 is the best at wide open throttle, right? But we're going to get 29 because we have a restriction here. So we got 29 inches here. What do we have right in this area?
Less.
A lot less, right? Because that's where the venturi is. So as long as we have less here and more here, it's going to work, right? Okay, why do you think they put this suction line here?
Mixture.
I don't know.
Okay, would that work? Let's think about this.
Oh yeah.
I don't have any directions for this. I just threw it up here.
It's
Okay,
already at full throttle.
So
because then it's open, and if you don't adjust with the suction, then you will always have too much pressure in the fuel reservoir, right?
yeah, can you guys see this? All right, so we're running full throttle.
Yeah,
So I'll make it full throttle. And then we now know that we'll call it, it's not ambient, right?
No.
Can you see that?
Mm-hmm.
Okay. So it's not ambient, but it's at least higher pressure than what we had before. And as long as this is open, it's going to flow through here and come into here. But at the same time, now that we're at wide open throttle, we do have suction right here. And it's going to take some of that away. Just a little bit, right? Just a peck, just a little.
it's in your sister.
So as I start closing this down and we start restricting this air coming in, what's going to win? Or what's going to happen to this yellow coming in? It's going to get weaker. It's going to get less. And so that means that
You're leaning
it's
out.
going to get leaner, right? So here we have a system that pretty much worked through idle cutoff all the way through, and it worked. It worked, yeah, it worked well off idle. So, all right. We looked at this one, needle type mixture control system. So, actually, needle type mixture control. So I'm going to say this one is, yeah, I made it work for something else before, but this is very similar to the Strombergs. The Strombergs have a rotating valve in it, but you can do the same thing with this one. And I'll repurpose this one. And so now we'll just say, okay, this is, I'm going to change it so Steve can see it in the back row back there. This is the float chamber now. And the only way out of this chamber is through this valve right here. So it's going to come out of this valve, through here, through the, what? Main metering jet, up here to the main discharge nozzle, or around here through the idle discharge. All right. So as long as I'm in full rich, this needle is going to be all the way up. Well, hey, thank you for doing that. All the way up and have no effect on anything. But as I want to lean out, I drop this needle in and I start closing this off. When this space here becomes less than this right here, what have you done?
Lean it out.
Metered it out. So that is your Marvel Shebler type. Just the only difference is the Marvel Shebler doesn't have a needle that goes up and down. It has a rotating valve. Otherwise, it's the exact same thing. This is that airport one that I talked about. So when this is closed, everything looks just like a normal carburetor, right? I mean, that's just normal to you guys. You've got a Venturi, you got a main discharge nozzle, you got a butterfly out here. But over here off to the side, there's just a second valve right here. And so all you do is open it up a little bit and adjust some air into here. And that's going to make it go?
Leaner.
Make it go lean.
Interesting.
Yeah.
So that doesn't actually save fuel.
No. No, because you're still going to measure the same thing here. Just add more air. It's kind of weird because I think in my head, maybe I'm wrong about this, but as you did that, you're introducing more air. More air is more RPM. So I think you'd actually probably have to adjust your throttle back a little bit.
Which, as you climb an altitude, you lose horsepower, right? So wouldn't this help you maintain? Because you're not cutting back your fuel when you're lean. You're just adding air. So would that help maintain horsepower?
But you will reduce the pressure on the Venturi.
I don't know. I don't see that.
Indirectly limit the amount of.
The pressure in Venturi will be reduced because
Yeah, because
the
of
amount
air
of
going
air
around
will
it.
be reduced.
Yeah, so if you had less going through here, then
So let's
you have
do-
2 ways to go. So 2 ways to go. Path of least resistance.
Mhm.
It's just not going to give you more power. If this is not something that you're going to see on a modern engine at all. I think the old large Strombergs did something similar to that. Not too many of them did it. But it's just, it's a way of doing things.
Jake brake for a semi truck, except for you're actually adding fuel in there instead of just compressed air.
Yeah, I'm not even sure how those work. All right, automatic mixture controls. All right, so we have here our bellows, right? And as we go up in altitude, does the bellows contract or expand? always expands. So it's going to expand, so that means it's going to push down. So what do we got going on here? Made metering jet. We got a suction back feed here. So what does that mean? We have suction on here. And the only way that we can get rid of that suction is to allow it to go out here. So right now we have an open area right here. So what's happening to this suction through this little line?
It's consumed by the ambient pressure. Which
Right, so ambient pressure is coming in here, filling this up, and oh, by the way, this is over here sucking it out, but who cares because this is larger than this, so there's all kinds of airflow coming through here. And that keeps the air from going stagnant too. That just doesn't matter. All right, so right now all the ambient's coming through, filling this up. A little bit's being robbed out of here, but that's okay. That just means you have some movement going around here. And I keep saying that because this is going to become a very important concept next week. That if you add a bleed to something, you have airflow. And airflow sometimes is very, very important because let's just say that this did not exist. And let's block it off. Okay, so now I have this pressure right here. And the fuel, yes, it's coming up here, but it's also going down here. So really, what's happening up in this upper chamber? To the air. It's exactly, Steve. It's absolutely just stagnant air. It's not hurting. It's not helping, but it's got to be there, right? So the fuel is coming in at the bottom, kind of swirling around, coming through here. Doesn't matter. Okay, so this area is stagnant. Now I go up in altitude and this bellows starts and it closes off. What happens to the air in here?
if it's closed, it's just the same.
So nothing's changed. Nothing has changed whatsoever. You can open this and close it all day long. This doesn't care. It's just air. It's like, yeah, I've got air. Doesn't matter. Doesn't make much difference. Well, you could probably argue about going up and down in altitude, but some minor differences. But for the most part, doesn't matter at all. What matters is that you have to have some, so when we're going to get into some situations where we're looking for airflow. And if we don't have airflow, then this doesn't do anything. It doesn't do any good. So you got to have some sort of airflow going on at all times. Well, this works a little bit more than that going on. So yes, we have our ambient coming in here. And then we also have our suction over here. So if we have suction here, and it's going to take some of that out. So as we go up in altitude and this starts closing off, that means that this is going to have more of an effect, and this can't fulfill all of the requirements. So this pressure is going to go up or down as we go up in altitude and this closes. It's going to go down. So if this pressure goes down here, goes down, the pressure becomes differential becomes higher or lower over here.
Lower.
Pressure differential. Is it matching?
Yes.
So if the pressure differential is getting closer together, the carburetor goes. Uh-oh. I feel like I've lost everybody. What happened? Where did I lose everybody?
Super lean. If it's
Yeah.
My confusion is about the needle valve.
Okay. This one right here.
Yes.
Okay.
It's not hollow, is it?
Yes, this is filled. It's hollow, filled full of air.
But the needle itself.
Oh, it's solid.
Okay.
That would be a confusing point. That's solid. So right now, there's space right here for air to get in and out. So as we go up in altitude, what's going to happen to this needle? Did it expand or contract? It expands. And as it expands, is this space right here going to get bigger or smaller?
Smaller.
This space gets smaller. So if this space gets smaller, what happens to the air pressure in here?
Lowers.
The air pressure got lower. Why?
Because it's getting sucked out.
Because it got sucked out over here. Okay, so this pressure gets lower as it become closer to the pressure here or further away? Comes closer. So if these two pressures come closer, then it gets
Less fuel.
less fuel, which is also called lean. Well, I guess I could have showed that first, huh? Maybe we'll do that. It's never too late.
Spring on the bellows,
Okay.
spring on the shaft.
This one looks like it does have a spring on the shaft.
Long lead, but
It can reset it, lift it back up.
it
So
wouldn't
it's-
do that on its own?
What?
It wouldn't do that on its own?
I'm assuming that if they put a spring there, no.
But with field,
Hey, look, I don't design them, I just fix them. I have a feeling I'm going to say that a lot.
It is vented.
oh, okay.
It's vented into the chamber,
Yeah.
but this is sealed. This is sealed.
Okay. But
So
the-
you have to have a vent into the chamber,
right.
otherwise this can't sense anything.
Yeah, but it works perfectly fine because the spring's just kind of supporting the bellow.
I don't want to argue with it. Sure. Oh, look, it's the same thing, but now that I've explained the bellows with the spring, everybody totally gets it. All right, Economizer Systems. Let's see what we have here. This is probably what I should have shown a long time ago with the needle with the parallel ports. All right, remember I talked about that one? I just made the other one work for me when I didn't need to. All right, so this is going to be pretty much automatically built in as we pull back the throttle, and this goes to wide open throttle. At the same time, it's going to lift up on this. When it lifts up on this, it allows fuel to come down into this passage. So up until that point, let's say we're at cruise RPM. Cruise RPM, we're at idle. We'll start at idle. Idle, this is going to be open or closed? It's going to be closed. And so idle fuel is going to come out somewhere else. And I advance it to, I don't know, 1,000 RPM. Fuel is going to come out this way through this main metering jet, up here and out. And everything's going to be fine. And I get up to 50% RPM, closed. 60% RPM, closed. Start getting up into 75% and above, this will start opening, allowing fuel to come out through here. Now, of course, this is going to do some metering, and meters a little bit of extra fuel will come through here. And then at some point, I'm going to go wide open throttle. This is going to be wide open, and so I have fuel coming through this jet and through this jet and mixing here and going up, and we have a rich mixture. And this one came out of your book, so that's the needle type. This is my piston, double piston type. So we talked about the double piston type at one point. Huh? We did. It's in your notes. It's a double piston type. I didn't say a lot about it. Why? Because I don't need to write a lot of notes. But again, this is something that once, at this point, you should start being able to look at these things and going, oh, I see what's going on there. So A, B, I don't know, what is A? A looks normal to me. So fuel comes through here. What do I have here? Main metering jet comes up through here. What do these little bubbles represent? Air. What is this right here? Main air. Man, you see, you guys are picking it up. Main air bleed comes down here, mixes, emulsifies the fuel, and out it goes. Well, now I want to richen it up. So as I advance the throttle, no, we're not at advanced throttle. As I advance the throttle, it's automatically going to push this little piston down a little bit. So this little piston opened up this chamber, which comes in here, and I believe some air mixes in through these little air ports right here. It comes down through there, mixes up in here, and we have a secondary way out, which made the fuel richer, and out we go. So there's just different ways of doing things. This is very similar to just another parallel path, right?
So on A, there's like a little valve or door that's closed to let the fuel in. That passageway is that closed?
Here?
Yeah,
Yeah, it just opens up right here and lets it in. So right here, it's closing it so it can't get in.
and it just opens up by the second spring. Second.
It's actually connected to the throttle. So it automatically happens as you open the throttle. As you open the throttle, it's going to push the pistons down, open up the economizer orifice, open up the air valve orifice, and let the fuel and the air mix and get in and be richer.
does the first piston push down onto the second piston? To push the second
Yes.
piston down?
So they're not connected at all? They're not connected?
I don't know.
The drawing is kind of.
Okay, old stuff, antique, never worked on it. Don't even have one. All right. Now, you know, every time I see this nice color drawing, this is in your textbook. So I'm assuming you guys already read this, so you can tell me how it works.
3 times.
All right. All right, so what do we have here? Economizer system. Let's go back a little bit. Would you call this an economizer or a power enrichment?
Power enrichment.
Would you call this an economizer or power enrichment?
Power
Did I already ask you that? How about this one?
Power enrichment.
How about this one?
Economizer.
Economizer.
Well, let's find out. All right, so here we have our fuel level, and right now it's coming through here, and it has 2 passageways. When does this open? That's what we have to figure out. Well, we have fulcrum, evacuated bellows, spring forcing this upwards to close, and a dash pot. Should we discuss what a dash pot is?
Yeah, that would probably be nice for talking.
Okay, I'm going to tell you this story, and I've yet to have anybody tell me that it's true. When I was an A&P student a long time ago, I made the mistake. We had I won't say his name, he's gone now, but he was not known as a well-loved instructor by a long shot. And I made the mistake of calling something the dashboard. What's a dashboard? When I say dashboard, what do you think I'm talking about?
Inside the car.
Inside the car.
Inside the cockpit? Okay, so I said the dashboard. Oh gosh, was that the wrong word to use? And so he tells me the story. You know what a dashboard is? Yeah, it's that thing. No. Well, he said that horses back in the old, and this is a true story. So this is what he told me. And I don't know if the story is true. He believed it was. Anyway, so horses, you know, as they're pulling the wagons and stuff, not that I have any experience with this. Anybody have any experience with this? Well, apparently horses pee a lot, and it would hit the ground and splash up on you as the driver. And so that was not a welcome thing. So they put boards up to keep that from happening, and they were called dashboards, and it was to prevent the horse urine from coming up and splashing. So the original idea of a dashboard was to keep horse urine off of you. So don't call it a dashboard because aircraft were never pulled by horses, thus there's no horse pee involved. So I tell you that story to, number one, ask if anybody's ever heard anything like that, besides Dennis. And number two, the fact that they call this a dash pot makes me think it's filled full of horse pee. So I cannot see that without thinking of that teacher and horse pee. So it is a dampener, if you will. And so it takes out fluctuations. And let's see.
Hydraulic or?
Yeah, we could do something hydraulic. Let me see. So if I had something, I'll just enlarge it. All right. So I had a shaft that came through here, and I put a disc on here that fit in there really tight, maybe some O-rings on the edge. But would this move up and down?
No.
It would. If this is full of hydraulic fluid on both sides, it would just hydraulic lock. It wouldn't move either which way. But if I take and drill some holes through it, make some little tiny holes, will this piston move up and down?
Yeah.
It will, but only at the rate that the fluid can transfer through these little holes. So you can see it really dampens. And really what I just drew is a shimmy dampener. I would say this is the same principle as what's going on with this little dash pot right here. Back to my laser pointer. All right, so we're looking for a bellows. So 2 manifold pressure. So this now is going to be sensing manifold pressure. So when I'm at idle, what is this chamber going to be filled with? A vacuum. Okay, so I have a significant vacuum. So what is my bellows going to do? Expand or contract? Expand. All right, so it expands. And because the fulcrum's right here, it's going to expand and push up. So what is this going to do? Close. So we know it's closed at idle. I go to wide open throttle. What do I have kind of pressure in here?
Almost atmospheric.
Almost atmospheric, which means the bellows is going to contract. It contracts. This goes down. So it is strictly sensing what?
Manifold.
Manifold pressure. So it's really not sensing. So is this an automatic mixture, or is this more of an economizer slash power enrichment system? Okay. Would you call this an economizer or a power enrichment?
Power enrichment.
I guess I could go either way. It depends on what, because it opens and closes. So, all right. Mid-range throttle. I've got a kind of a mid-range pressure in here. It's hard to say. I don't know what this is calibrated to do. This could be partially open, whatever the designer wants. But you can see it's not a big deal how that works. Everybody follow that?
Mm-hmm.
All right. All right.
I got a question.
Okay.
Economizer, I thought it was the same thing as a power management.
It is. It actually is. As far as all textbooks are concerned, it's the same thing. It was my verbiage where I said, if I could rule the world, I would make everything that makes a carburetor go richer, I would call it a power enrichment, and everything that made a carburetor go leaner, I would call it a economizer. But that's not accurate, and that's not what books say, and they didn't ask my opinion. So, all right, let's see if I can make a mess out of this here. Okay, this is your model for SPA. When you're talking about your Marvel shovelers, just because you see well, I don't want to say that. Model 4, there's a lot of different Model 4s. And some of the Model 3s are very close to the Model 4s, so you can actually use the same drawing. That's why Marvel Shoveler did this. So what I'm looking at here, and this is not going to be too easy for you, is what is in this area between here and here, this little area right in here. What's going to be behind all of this?
Or butterfly.
Right, you can see it right here. So this is going to be my throttle body, is another term for that. And I have the butterfly right in there. And right now, let's see, if we have this butterfly in here and it's at this position, what am I at? I'm at idle, okay. So if I'm at idle right now, what kind of pressure do I have up here? Vacuum, suction, I like all that. Very low pressure. Manifold pressure is going to be very low. What do I have down here? Because remember, this is an updraft.
Atmospheric.
So this is atmospheric. So I want you to note that right now, this is the float bowl. This is the airspace. There's a line going through here, and that line goes up to right here. And so what is on this line right here?
The idle discharge?
Economizer hole. So what do you think's going to, what's it trying to sense right here?
Throttle position.
Throttle position. All right. There's a little more going on in this drawing I think we want to go. But what you're going to be looking for is as this, here's the throttle valve here, wide open. As this throttle valve starts moving and it starts coming down to this area right here, what's going to be subjected to, what's going to come through here? Vacuum. So as I go to kind of a mid-range throttle, that's mid-range throttle, what's going to happen here? Pressure's going to drop, which makes the pressure drop here, which makes the carburetor do what?
Lean.
Start to go lean. But then I get to wide open throttle, and what kind of pressure am I going to have here?
Close to ambient.
Okay, if we say close to ambient, then what happens here?
Goes rich again.
Goes rich again. So what do we call this?
Richmond.
I would call this the true economizer. Because if I blocked off this passage right here, the carburetor would be normal at idle. It would run richer at mid-range than with it open. And with it closed, it'll run the same at full power that it would have run before. So it really doesn't have much to do with anything. There's some other things going on. Doesn't show it real well in here where these passages go. But note that this one, when you get into this, look for this one. They should have colored it, but they didn't. So it's kind of hidden in there. Because it doesn't say fuel or air. It should have.
What?
It should be air.
I couldn't figure out, what is the screen for?
When you see a screen, it's just a block dirt. Okay. So this is the... Wow, I don't want to get into this one right now. Probably not. Well, let's take a look at it, I think. Let me see what else we got. 4-5, we got that. Okay, we talked about this yesterday. We can skip that one. I used to have you do the 4-5, and it's a much larger carburetor, and it uses a needle up at the top, oh, there it is, right there, to actually control how much pressure is up here. So what happens as you go add more throttle, it's going to change this needle valve, which is going to change the pressure up here. It's going to either it's going to bleed it off a little bit. So, all right, talked about that. It's kind of a complicated thing. So I made it the last project, but it's just it's the same thing. It's the same principle. It's using Venturi air, and then the needle will either bleed it off or allow it to stay. So that's all it is. All right, Stromberg. So the moment you've all been waiting for. So, all right, what are my components here? What is this? All right, so if we're talking about, and you're doing your oral, and I say, well, start at the beginning. And it's surprising when people go, well, the beginning, you have fuel coming out of this discharge nozzle. I'm like, whoa, start at the beginning. So start at the beginning, we have a fitting here. What kind of threads are in this right here?
Pipe threading.
Pipe threads. What happens if you screw pipe threads in too tight? It doesn't strip out.
It kind of welds together.
You get a nice crack forming right across here because pipe threads, as you turn it in, it wedges in. And the tighter you make it, the more pressure. And so it gets to a point where it just explodes this out and you put a nice big crack on here. Well, if you crack this, what do you do?
Buy a new carburetor.
That's easy. You just buy a new carburetor. All right. Next thing you go into is a screen. Okay, it's a screen. What happens if the screen gets plugged?
You get no fuel.
You get no fuel. Is there a bypass?
No.
Negative. No bypass. So I guess the theory is, before it was like, well, bad oil is better than no oil. Well, maybe in this case, you can't really say bad fuel is better than no fuel because if the fuel's got a bunch of contaminants, it's going to block up all the passages. What was the point? I don't know. Wasn't my decision. All right. So, and how often should we change that? Pull that screen out.
Every 100 hours.
Manual says every 100 hours. So every 100 hours. There's also a plug on the bottom right there. And it would be a really good idea to take that plug out at the same time because any water that accumulates in here just stays. And that water starts corroding really bad down there. All right, what is this right here? Main metering jet. Notice what holds that in place?
Nothing.
Gravity. Nothing. It's tight. You guys remember when Harrison Ford crashed his Ryan plane? It was a Ryan PT what? Wasn't that long? Was it PT? Yeah. You know why he crashed?
No.
Lost that.
This came out.
Really?
It was a different Stromberg type carburetor, but this just backed its way out and he crashed. Because how well is this going to run without this?
Not well.
What's it going to do?
Very rich.
It'll super rich and die. All right, this right here is the...
How can it come out?
It just vibrated out after all. Nobody ever checked it. And the NTSB said there's no check on it. There was no maintenance alert or anything. It just happened. But it had been decades since it had been checked.
If he would have known, could he have leaned it all the way until it would have stabilized? I guess.
Depends on what kind of mixture system he had. So once it died, I don't know.
He was close to the ground too.
Very
wasn't he?
close, yeah. And honestly, my engine loses power. I'm going to do everything but lean it. It's just it's not going to in my head, All right, what is this called right here?
Seat.
Okay, what are these little holes for?
Safety wire
Safety wire. What does it get safety wired to?
to the hole.
To the hole right here. Why'd you do that? You guys are way ahead of the curve. All the other classes I always ask that. What's that hole for? And I just listen to all these crazy ideas. I never make anybody suffer, but I always end up telling them, nah, it's just for safety wire. But it's fun to listen to everything. All right, this right here is the idle discharge. This is the main air bleed and the something interesting. You know, there's a lot going on here that we don't really appreciate. This is the main air bleed, but what goes right on top of it right here? Piece of metal. So the only way air is going to get into that is to do what? Got to go up and make a U-turn. Well, I bet they did that on for a reason. Why would I want to do something like that and make a U-turn?
Increases meter rate.
No.
No humidity.
Temperature.
A little piece of dirt.
Okay.
That dirt comes up and it hits the top. Do you think it's going to make the corner and come back around? Or is it just going to kind of fling off the other way?
Fling off the other way.
I think it's kind of a filter. It had a little homemade filter there that never has to be cleaned or checked. So I think that's kind of cool. By the way, this should be safetied around this right here. So I'm asking everybody, please, if you heard nothing else today, I don't want these to come out anymore. They're too fragile and they're irreplaceable. So I'm going to have you safety them, make sure that there's two gaskets, safety them, and then that's just going to be it. They're going to not come apart anymore.
Make sure you torque them before you safety.
Okay. Make sure you torque it to half. Fuel comes in here, goes through the strainer. We check the strainer every 100 hours. There's a plug back here. We'll take the plug out. Comes up through the main needle and seat, fills this up. This rises off, blocks it off. What happens if the float level is too high?
No fuel.
It comes out
It drips out of here all night long. And we know that because we have what? Blue stains is exactly correct. If the float level stops and it's too low,
It won't start, it won't go past idle.
well, we have a hard time pulling fuel up. I think lean is the best answer. If it's just a little bit too low, it's going to run a little bit too lean at all settings off idle. All right, so I ask you to tell me about the idle circuit, and we're going to start there. So fuel is going to come through the main metering jet. Is that doing anything right now? No. Comes up and it fills this full of fuel. And it's going to fill this full of fuel. And it's just going to sit there. But in a different view, fuel's coming up and going. So it's right here. This little area right here. It's coming out that way. Right there. It comes up and it goes to, what is this called? Yeah, just read right there. Idle metering jet. And at that point, there's some holes right beyond there. And what is getting mixed here? Air and fuel. So I'm going to ask you, where did this air come from? And you're going to have to locate on the carburetor the exact spot where air comes down that tube and mixes in, and it comes up and it emulsifies it. And we have how many discharge points? 2 discharge points. Why 2?
Throttle position, or
How about because it needs twice as much fuel as 1? It's not a real complicated answer. 1 wouldn't be enough. Needs 2. But the second one we can control with the idle mixture adjustment. All right, so fuel's going to come out, go through here. Why is fuel being drawn out here? Because there's a significant vacuum from the pistons, right? Okay, and there's a differential between here and over here. That's going to draw it out. Okay, so wide open throttle. All of that fuel that is sitting right here, up in here, is going to get drawn out. So we're going to get instantly a rich mixture. That's just going to happen. So we're going to get a rich mixture as it comes out. And as we transition off of that, off of the idle, and that's going to draw the fuel out. Now we're running, and we have, of course, the idle air bleed here, which the main air bleed. The air comes up, has to do a U-turn, so maybe it gets rid of some dirt, mixes in here, and off it goes. I think everybody's kind of got that. Let's talk about this because I still see a lot of confusion about this. Yeah,
If the bowl is cracked,
bowl is cracked.
it will just run rich, right?
The bowl? What bowl?
Or the plug.
The float is cracked. What happens if the float has a little tiny hole in it? Just enough that it sinks a little bit. Well, then the fuel level is going to come up. And if it's not running, it's going to run out of here. If it is running, it's going to run rich. So anytime the float is compromised, it's going to start running really rich.
So the dents that are in our float, that affects
The what?
buoyancy? If there's a dent in the float, that would affect the buoyancy?
Well, if you have extra solder, it's weighted, anything along that nature. I don't know if the dent will really affect it because you still have the same air in there. But anything that affects it, that's why you have to adjust the seat. So you can, it's not unusable necessarily unless the book says no dents, but you put it together, you adjust the float. What if your float level's too low? What do I do?
You adjust the seat.
Up or down?
Lower the seat.
Lower the seat. If the level's too low, lower the seat. Level's too high,
Raise
Raise
the
the seat.
raise the seat. You guys are getting antsy. All right. I'll let you go stand by the time clock. Well, yeah, we'll talk about that tomorrow.